In this math counts preparation lesson, we're going to be focusing on optimization. So let's get started. You've probably heard of optimization before, and you've probably heard about it in calculus, if you ever heard about stuff like calculus is what you think of when you think of optimization, but we're not going to be doing calculus today because we're doing it for math counts. We don't need calculus. These are just problems where we're trying to find the minimum value or the maximum value of something, whether it be an expression, an equation, some logic problem. So there's lots of different applications of optimization. Now, optimization is basically problems where you just, what I said, minimum, maximum, something. So I like 3 steps which you can take to solve any optimization problem where you find either equations or expressions. Even in traditional, not traditional, but like optimization problems where there's no equations or expressions, something else, like some logic optimization thing, try to find and reduce cases as you go by. So, step 1, inequalities. Think inequalities. When you see an optimization problem, think of inequalities. Step 2, get into the problem and find what strategies you need to do such. So if you're dealing with addition, subtraction, multiplication, or division. So it really honestly depends on what you're trying to do. And then the third step is just, I'm going to label these, is just S1 plus S2. And first we're going to go into the inequalities. We're going to go and try to reduce cases, find an inequality within the expression or equation which we're dealing with. Step 2 is simple. We just try to figure out what we're dealing with. We're trying to deal with addition, multiplication, subtraction, or addition. Step 3 is just using the restrictions we've done in this case and in this case. Take these two and add them together and then go to this case. So it's basically what we're doing here. We're first going in for the inequalities. If we can't find inequalities, move on to here. Again, just test some values for the variable, see what you can find, and then go in to this last step. Now, this last step is is the least important part. The most 2 important steps are these steps. These are the most important steps. These steps are the ones that will lead you to the answer. And that's basically all you need to know. These are basically just logic problems. You have to think about the problems more. So let's get into the problem. Today's problem comes from the 2010 school target round. It's problem number 7. So it's one of the harder target problems on there. So 2 distinct integers, m and n. We're dealing with integers, m and n. So I'm going to underline integers. M and n are chosen from the set 1, 2, 3, 4, 5, all the way to 2009. And we're looking for the maximum possible value of this expression right over here. We're looking for the maximum possible value of 2m plus n divided by m minus 2n. Alright, step 1, look for inequalities. Right, step 1, look for inequalities. What can we find in here? Well, I see this m minus 2n. Now we're trying to find the greatest possible value of 2m plus n divided by m minus 2n. Now let's see what happens if we're looking for inequalities. If here we have addition. Addition doesn't matter. We can have n be greater than m. It doesn't really matter. Or m be greater than n. But it doesn't really matter. But subtraction, we might have a negative here. And if we have a negative here, we can't have the maximum possible value. So then we want a positive value. Since negatives, those are too small. So we can concur that m must be greater than 2n. key thing here is m must be greater than 2 times n. This is because if m is less than 2n, then we can have something like, let's say I pick 4. Hypothetical. Let's say I pick m equals 2 and n equals 4. Then when I substitute in for this expression, I have m minus 2n. And I have 2 minus 8, which gives me negative 6, which is small. And then I have to find the denominator, and I have to divide them, make it even smaller. So this inequality is true. We have to have m greater than 2n. Alright, now that we have the inequality part, I don't see any other inequalities. Let's focus on what we're dealing with. We're trying to find the maximum possible value of division. Look at the operation, division. Now, when we're dealing with division, what makes a quotient of two numbers the greatest? Let's just think about this for a moment. If I have the quotient of two numbers, and I want to make them as big as possible, I have to have the numerator and the denominator to have the greatest difference possible. So the numerator minus the denominator needs to be as big as possible. The difference needs to be as big as possible. And difference, subtraction. So now we've turned this division mess into a subtraction mess. So now we have 2m plus n. Because really all we're doing is we're looking at the subtraction aspect of it. Because this is really just modified subtraction. We just want to find the greatest possible difference of the numerator and the denominator. And it's going to be minus m minus 2n. This whole thing over here we need to subtract off. And now we can just combine like terms, simplify the expression the usual. I'm going to do this, negative m plus 2n. I'm going to combine these like terms, 2m and 2m minus m gives me m, n plus 2n is 3n. I'm going to rearrange that. So now we have the greatest possible value of 3n plus m when m is greater than 2n. Okay, so m has to be greater than 2n. That's all we know. And that overall just means that m just needs to be greater than n. So if m needs to be greater than n, and we want to find the maximum possible value of an addition problem, we need to make m as big as possible, right? So we're already at such a big number, and then we add on 3 times another big number. So now we have a strategy. Now we have a strategy, and we can just set m equal to 2009, the largest number in this set. And now let's take a look at 3n. I'm going to forget about the 3n. I'm just going to focus on the value of n. We want n to be as big as possible. Now, I'm going to take a look at this inequality. This inequality states that m must be greater than 2 times n. So this means 2009 must be greater than 2 times 2n. So now, all I need to do is to find the greatest possible value of n. I just need to do 2009, and I need to divide it by 2. Now, once I've divided it by 2, I need to make sure that m doesn't equal 2n. Because if m equals 2n, then this equals 0. So m has to be less than 2n. So whatever I get over here, I can already tell 2009 isn't divisible by 2. So I'm going to get a decimal. So when I'm getting my decimal, I need to round down, since that's going to be satisfying this inequality. So let's just do this. I noticed that I'm dividing by 2. And dividing by 2, when you're dealing with stuff like this, finding the decimal is not that hard. First, I'm just going to make this easier, and I'm going to do 2008 divided by 2. And this is just 1008 and 1004. If I did that right, which yes I did. 4 times 2 is 8, and I have zeros, and then I have a 2 at the end. Alright, and now since we have a 2009, we have a little extras here. I'm gonna have a 1004.5. So now some easy division. We have 1004.5. Now this is if we just take half of m. Now we want n to be 2n to be less than m. So if I take double of this, I just get m, which I don't want, since if I set this equal to n, well then this denominator is going to be 0, and then I have an undefined number. Since anything divided by 0 is undefined, and 0 divided by 0 is indeterminate. So we have to round down, so this means that n, the greatest possible value of n, again, integers. I can't have a decimal. So I can't have 104.4, I need to have 104, which is the greatest integer if you round down. And now we have m and n. Now, all we need to do is stick m and stick n into this expression, and then we'll get our answer. Now let's just do that. Let's rewrite our expressions. 2m plus n over m minus 2n. What do we have? We have m equals 2009. We have n equals 1004. We have m minus 2n, so we know m is 2009 minus 2 times, we already know that's 1004. Alright, so the only sort of thing I don't know how to do in my head is 2 times 2009. So I'm going to go ahead and I'm going to do that out right here. That's not as easy to compute, but we'll go ahead and do it. Of course, on a target round, we get calculator, so you can just quickly compute this using your calculator. But since I don't really have a calculator here, I'm just going to do it without one. So this results in a 1, 0, 4. And now I have 4018 plus 1004 over 2009 minus 2 times 1004. 2 times 1004, we have an 8 in minus digit, and these two are zeros, and 2 times 1 is 2. So we have 2009 minus 2008, which is 1. So now we know we've reached the maximum possible value. We're sure our answer is right because this denominator is just 1. So now the greatest possible value is just this up here. But of course, that's not in simplest form. Let's go ahead and put it in simplest form. Let's go ahead and add this. 8 and 4 is 12. 1 and 1 is 2. 0 and 0 is 0. 4 and 1 is 5. We have 5022 over 1, which is just 5022. So, the greatest possible value of this expression is 5022. And again, we use the key optimization strategy. Step 1, inequality. Step 2, look at the operations. Here we had division, so we turn that division into an addition. And optimization with addition is so much easier than optimization with division. And then step 3 is combining those two to find values of m and n that make this expression as large as possible.